Hey, Vsauce, Michael here. I've been watching Bravest Warriors on Cartoon Hangover lately. It's great. It was created by Pendleton Ward. And in the show, teenagers zip around the universe visiting star systems and planets. And here is my question. When will we do the same? Us humans in real life. I mean, we've managed to put people on the moon and land robots on asteroids and Mars, and even Titan, a moon of Saturn. Interplanetary travel is scary cool, but will we ever travel interstellarly? Certainly it will happen, right? I mean, Voyager 1 is expected to reach interstellar space sometime this year, or maybe in the next year or two, and it was launched way back in 1977. So shows like Bravest Warriors are pretty much just a glimpse of our future, maybe even one within our lifetimes. Right? Well, we're going to need a dong for this one, something you can do online now, guys. The Hayden Planetarium's digital universe allows you to explore a three-dimensional map of our Milky Way. Now, there are about 81 visible stars within just 20 light years of our own sun. The nearest is Proxima Centauri, which is only 4.3 light years away. Getting there? Piece of cake. Piece of difficult cake. Because a light year is an incredibly long distance. It's the distance that light in a vacuum will travel in an entire year. And in just 1 second, light can travel so far as to circle the entire equator of Earth. 7 times. Now, a fast bullet can travel at about 1,500 meters per second, and Voyager 1 is traveling at about 17,000 meters per second relative to the Sun. Also relative to the Sun, our Earth is orbiting at a speed of 29,800 meters per second. That's pretty fast. But the fastest man-made object ever was the Helios 2 solar probe, which traveled at a maximum speed of 70,220 meters per second. Impressive, right? Well, even at that speed, the fastest speed ever reached by any man-made object, crossing this little old gap and reaching Proxima Centauri would take 19,000 years. But technology in the future is bound to be improved, along with the maximum speeds we are able to obtain. Even using what we know now, a solar sail could easily provide the acceleration needed to reach near light speed speeds. And our current understanding of physics theoretically allows for things like wormholes, which in theory could move a spacecraft from one point in space to another faster than light normally could. And who could forget the famous Alcubierre drive, an idea that fits within most models of our universe and proposes a way to deliver a spacecraft to a distant object faster than light can get there, not by moving the spacecraft, but instead by collapsing and expanding space itself. Things like wormholes and Alcubierre drives are theoretical, but if they could one day become a reality, how far away might that day be? It matters, and figuring out exactly when in time we should begin an interstellar journey is called a weight calculation. Leave too soon, and before a ship launched today full of frozen embryos ever got to its destination, it would be passed by astronauts who left hundreds or thousands of years later at a point in time when technology was advanced enough to lap what we have today. Andrew Kennedy calculated that given the pace of our progress as far as travel velocity is concerned and Earth's mean annual economic growth, the soonest human civilization might ever reach Barnard's star, 6 light years away, is 1,104 years from today, which isn't within any of our lifetimes. It might also be a bit optimistic, because it assumes that we not only solve the problem of speed, but that we also solve problems like how to survive interstellar radiation for years, or how to avoid collisions with interstellar material at high speeds. It also assumes that before we achieve the technology needed to successfully interstellarly travel, all of humankind isn't wiped out by some cataclysmic natural disaster. It may sound unlikely, but we're not talking about the near future, we're talking about thousands of years from now. Let's put it this way. Even given our current slow means of space travel, it's estimated that within 5 to 50 million years, we could theoretically explore and colonize our whole galaxy. That's a lot of time, though. In fact, statistically speaking, within the next 500,000 years, it's very likely that Earth will encounter a meteorite nearly a kilometer across. Hopefully, when that happens, we have the prevention abilities needed to keep ourselves safe. But given all of this information, it's easy to see why the 2008 Joint Propulsion Conference concluded that it was improbable that humans would ever explore beyond the solar system. It's quite depressing to think that scenes like this one from Shutterstock may be destined to only ever remain that, science fiction. Wait, how quickly is the camera moving in that clip? We're used to seeing science fiction scenes like this, but a nebula tends to be light years across, which means that in this clip we are traveling at least the speed of light, if not faster. Would it really look like that? I covered this briefly in my black hole video, but not completely. If you were to travel at the speed of light, or near the speed of light, the universe ahead of you wouldn't look like it usually did. First of all, your field of view would increase. It would appear as if the universe was receding away from you as you accelerated. At the same time, all of the light reaching you would be blue shifted until you were left with this. You may have seen this on Vsauce too. It's the cosmic background radiation blue shifted all the way up into the visible range. MIT Game Lab offers a free downloadable game that puts you in an environment where the speed of light can be lowered all the way down to typical walking speed. You can experience all of the visual effects I just discussed, but I wanted to know what it would look like if the speed of light was where it is, and I took a journey from Earth to the moon. So I enlisted my friend Liam from World of the Orange and New Music to put together a simulation of what it might actually look like to accelerate to nearly the speed of light and then slow down during a trip from Earth to the moon. Enjoy. Whether or not you should believe that all the right factors will come together and humans will one day travel that quickly or reach interstellar destinations largely comes down to whether you want to be an optimist or a pessimist. But what we've accomplished so far is quite amazing, considering how weak, flimsy, and vulnerable the human body is in the vacuum of space. Bad Astronomer and SciShow have great videos discussing this topic, and now, thanks to the brilliant team at Bravest Warriors, I'm going to go to space. But not while wearing a Vsauce suit. No. I'll do it naked. Well, okay, no, not that naked. And also maybe some muscles? Yep, so that's pretty much what I would look like. The moment I'm exposed to the vacuum of space, my body would not inflate and explode. Now, the body's a very nicely contained system, but those parts of me that aren't well contained, they'll be the first to go. The air in my lungs and digestive tract would quickly rush out. Moist, soft tissues would rapidly lose water. My mouth and lips and eyes would dry out and swell. As water was pulled to the surface of these things, it would vaporize, and the decrease in its pressure would cool my mouth and eyes to near freezing. My body would inflate to about twice its normal size as gases in my blood came out of solution, slowly evaporating away, cooling the surface of my skin. Oh, and the blood vessels in my eyes would likely burst, spilling blood into my eyes, which, along with all the other fluid in my eyes, would be rapidly vaporizing on the surface, freezing and drying them out. Within about 15 seconds, I would go unconscious because oxygen wasn't reaching my brain. And as far as I'm concerned, that would be the end of the entire ordeal. For another 90 seconds or so, I would still technically be alive, but I wouldn't be aware of it or remember any of it. My dead body would remain internally quite warm for a while, because in the near vacuum of space there isn't much matter to conduct or convect heat away from me. Instead, I would really only lose heat through radiation, a much less efficient method. It would take hours for me to cool down to the temperature of space, and by then I would be nothing but a dried up piece of slightly bloated and stretched, desiccated human jerky. If I was exposed to the sun's full-on radiation, not filtered by the usual atmosphere of Earth, I would be a grossly sunburned piece of jerky. In case that makes you hungry, let me give you some nutritional facts. 200 pounds of human meat in outer space would eventually become about 120 pounds of freeze-dried jerky. And given what would be left of me that would be edible, as a snack, I'd be worth about 115,000 calories. Maybe humans are the only intelligent life in the universe. But if you believe that intelligent life could have arisen on other planets, an interesting idea occurs: the Fermi paradox. Enrico Fermi calculated that given the number of planets believed to exist in our galaxy, at least some of them must have been habitable to life as we know it, and in many cases, millions and millions of years before life on Earth even existed. So if interstellar travel, traveling between stars in different solar systems, really is possible for intelligent life to do, why have we not been visited by aliens yet? Well, maybe we have been visited. Maybe they're here right now and we just can't perceive them. Or maybe we haven't been discovered. Or maybe we are alone. Or maybe we're just not worth visiting. So what are you waiting for? Live your life in a way that makes traveling light years just to hang out with you worth it. And as always, thanks for watching.